So next we have the law of cosines. But why do we need the law of cosines while we already have the law of sines? Well, remember that we can only apply the law of sines in an oblique triangle if two angles and a side are known, or if two sides and an angle opposite one of them are known. So if the two sides of an oblique triangle and the included angle are given, or if the three sides are given, then that's the time that we can now apply the law of cosines. But first, let me show you how this law of cosines was derived. So consider this triangle on a coordinate plane such that the vertex of our alpha is at origin or at point 0, 0, and side C lies along the positive x-axis. And if U and V denotes the length, then the coordinates of the vertex at gamma are U, V. If cosine alpha is equal to, we know that it is equal to the adjacent over hypotenuse, so that is U over B. And if our cosine alpha is equal to U over B, then U is equal to B cosine alpha. So similarly, if our sine alpha, and we know that this is opposite over hypotenuse, so that is V over B, then V is equal to B sine alpha. So if U is equal to B cosine alpha and V is equal to B sine alpha, then the coordinates of the vertex at Y are B cosine alpha and B sine alpha. So since we have these two coordinates, we have B cosine alpha, B sine alpha, and C and 0, let this be our x sub 1 and this be our x sub 2, then y sub 1 and y sub 2. So using our distance formula, we have this equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So let us just replace b with a. So substituting, that is our x sub 2 is b cosine alpha minus our x sub 1 is c squared plus our y sub 2 is b sine alpha minus our y sub 1, which is 0 squared. So that is equal to the square root of b squared cosine squared alpha minus 2bc cosine alpha plus c squared plus b squared sine square alpha. Now let us get their common factor, that is b squared. So square root of b squared times cosine square alpha plus sine squared alpha minus 2bc cosine alpha plus c squared. In the Pythagorean identity, adding cosine squared theta plus sine squared theta is equal to 1. So cosine squared alpha plus sine squared alpha is also equal to 1. So that is equal to square root of b squared. Since that is already 1, so b squared times 1, that is b squared minus 2bc cosine alpha plus c squared. Or it can also be written as b square root of b squared plus c squared minus 2bc cosine alpha. So that is now our a. So squaring both sides is a squared is equal to b squared plus c squared minus 2bc cosine alpha. And the two other equations are derived in the same way. So that is only for side A. And we notice that in side A, in finding the side A, what is involved here is the two sides, which is B and C, and they're included in cosine A. So in side B, or your B square now, in finding that, what is involved here now is the two sides A and C, so that is A squared plus C squared minus 2AC cosine beta, and beta is their included angle. And same with side C, or our C squared, so that is equal to A squared plus B squared minus 2AB cosine gamma. So manipulating these three equations, so for example, in getting alpha or cosine alpha, so from this equation, plus c square minus 2bc cosine alpha, let us transpose negative 2bc cosine alpha in our left side of the equality, that is 2bc cosine alpha is equal to, then let us transpose a squared to the right side of our equality symbol. So b squared plus c squared minus a squared. So dividing both sides by 2bc para maiwan si cosine alpha sa left. So cosine alpha now is b squared plus c squared minus a squared all over 2bc. So that is now the equation in getting the cosine alpha. You can also do the same in getting the cosine beta and gamma. So in cosine alpha, that is b squared plus c squared minus a squared all over 2bc. And in our cosine beta, that is a squared plus c squared minus b squared all over 2ac. And our cosine gamma, that is a squared plus b squared minus c squared all over 2ab. So let us have an example. Solve the triangle where angle gamma is equal to 49 degrees, or side A is equal to 29 and B is equal to 39. So you can already draw the triangle and locate the given measurements para mas ma-imagine nyo yung kalalabasan. So here, since side A and B are given and together with their included angle, which is 49 degrees, then we can already find for side C with our formula c squared is equal to a squared plus b squared minus 2ab cosine gamma. So our a is 29, so that is 29 squared plus our b is 39 squared minus 2 times our a, which is 29, times our b, which is 39 cosine 49 degrees. So that is approximately 841 plus the square of 39 squared, 1521 minus 2,262 times our cosine 49, 0.6561. So that is approximately 2,362 minus 1,484.0982. So our C now tinanggal natin yung square. So, that is square root of 877.9018. And C is approximately 29.63. So, that is now our side C. And since kompleto na yung sides A, B, and C natin, we can already solve for our cosine alpha. So, cosine alpha is equal to B squared plus C squared minus A squared all over 2BC. So, substituting the values, we have 39 squared plus 29.63 squared minus 29 squared all over 2 times 39 times our C, that is 29.63. So, that is equal to 1,521 plus 877.94 minus 841 all over 2,311.14, and that is approximately 1,557.94 all over 2,311.14. So our cosine alpha is approximately 0.6741, or our alpha now is approximately 47 degrees and 37 seconds. Now, the simplest way in solving for our beta is we will just subtract our alpha and gamma from 180 degrees. So that is 180 degrees minus 49 degrees plus 47 degrees 37 seconds, and that is approximately 83 degrees 23 seconds. So that is now our beta. So kompleto na yung measurements ng ating triangle. So now it's your turn, class. Use the law of sines and cosines to find the missing sides and angles of the following triangles. So please copy and answer 1 to 5 and pass it in our Edmodo.